Hey everyone! In our previous video series, I talked about the fields, the different fields in Django, and the default Django admin. So now you have an idea of the different types of fields that go into models. You know how to build models, you know how to test models. So obviously, because this is a software tools class, and I've been talking about best practices. Obviously, we need to talk about best practices when creating models. So in this um, very short video, or slide set at the very least, we'll talk about model inheritance, um, how to manage Django projects, custom managers, proxy models, and the concept of fat models. Model inheritance. When you create your Django models, you already use inheritance in the form of extending the default models that model class. Okay, but when you're trying to manage a larger application wherein different subsets of your models might have some very subtle differences, it would not make sense to create a completely separate model. Instead, you use what's called a proxy model. Okay, so by having a proxy model, the idea is you would still have the same database table. However, in memory or in the Django application itself, it is Django that adds whatever special functionality you have declared in your proxy class. Okay, so that is when you're using proxy models is you um, extending a concrete class. Okay, so that you don't do multi-table inheritance wherein you're extending a concrete class. Instead, you're just creating um, an object that acts like your original concrete class. Okay, and then aside from leveraging proxy models, you can also leverage abstract base classes. Okay, so here with abstract base classes, you are still um, using implementing models.model to create an abstract class. But by being an abstract class, it doesn't get um, committed to the database. Instead, you have to create a concrete class, okay, that implements your abstract base class. Okay, and this is good when there are a lot of overlaps between your models. A very common example that you would find online is a model called a timestamp model, wherein you would have you would have something like this. Okay, you have your created on field and a modified on field. So these are fields that you would normally see in your database because you want to be able to see when a certain model was updated or when a certain model was created. Okay, so again, abstract classes don't create database tables. To say that it is an abstract class, you create an inner class named meta in your model's definition, and then say abstract is equal to true. And by doing that, you're creating an abstract base class that can be implemented later. Okay? And in terms of models, a common question would be, when would I need a different app? I could theoretically just put all my apps in one, or all my models in one app. Okay, the idea is when there are too many models, the apps should choose from there. AKA, um, if you find yourself having a lot of models, it's definitely time to create more apps for them. Find where you can separate them into their own small package. And then when working with models, you would need a database design. this is not a database class, so we'll not be talking about that. Instead, this will be tackled in the next regular semester under your information management class, or CSI 41. Okay, and then the next way to kind of work with your models is through custom managers. I've talked about this. So when working with custom managers, a good rule of thumb is to not overwrite the default objects manager. Instead, when creating a custom manager, define the objects manager followed by the custom managers. Okay, so this does two things. It prevents unexpected behaviors when doing inheritance, because they inherit the objects manager from the parent. And overriding default manager, though overriding the default manager can be acceptable if you're creating proxy models, because they aren't stored in the database anyways. Okay, so an example would look something like this. Okay, I create a custom manager that returns a custom query set. So now, every time I do, and then in a concrete class, I use objects equals models.manager, and then custom equals custom manager. Okay, if I did it such that I said objects is equal to models.manager, okay, every time I say concrete class that objects.all, I would get a filtered out query set already. I'm not getting everything. Okay, and obviously that's gonna lead to a lot of bugs. Okay, so you want to always use a different name for your custom manager unless you are using proxy models. Okay, so like I said, with proxy models, this is how you define a proxy model. This is a finished task. Okay, so that is a subset of a task. Objects is equal to finished manager, but I say class meta, so again our inner class meta, and then say proxy is equal to true. In a previous example, when we created an abstract class, we used abstract is equal to true. In this case, we use the proxy attribute. Finally, when architecting your application, the common adage is fat models and thin controllers. Okay, so the idea is most of your business logic lives in your models, and then your views and or templates are very thin. They only deal with sending out what is going to be rendered on screen. Okay, so in Django speak, your views, your view classes, your class-based views or function-based views should not have a lot of logic in it. Instead, they should live in the models. Okay, so that, how does that happen? You can create model methods, properties, or custom manager methods. Okay, you can add methods to your managers to do a lot of stuff. But if you see your models becoming too big, there's no harm in creating utility functions in autils.py in the same application as a sibling to your models.py. Okay, no problem with that. Obviously, those are utility functions that will help you clean up your code in your models.py to get it to a more manageable and readable size. Okay, and with that, we are done talking about best practices. In our next video, we're going to be talking about how to move your applications from SQLite to actually using Postgres.